Hi, welcome to an ESP32 tutorial from Robojax. My name is Ahmed Shamshiri, presenting this tutorial from Canada. In this tutorial, we are going to learn how we can control more than one servo motors using ESP32 and Bluetooth. For example, I have now 4 push buttons for each 4 servo. When I press it, the servo moves to the location 0 to 180 and comes back. And you can put your own upper and lower limit of angles. Or if you select mode 2, it goes from 180 to 0 and returns back to 180. You can get the code for this by clicking at the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. In my old videos, under the video in the description, click show more and you will see the link directed to different section of the video. You can click on any of these links to jump directly to different section of the video. There are applications that you need to control, either a smart car, a smart robot, robotic arm, or whatever it is that you need to do, and you want it to control each servo remotely at different angles. So I've written this code. I've used an available library for servo, which was not working for ESP32. With some modification, I made it available so it doesn't conflict with current existing servo library, and I called it servo_ESP32. So I have a lot of other videos explaining how to use it without Bluetooth directly, and also with Wi-Fi. The links for those videos are below this video, but in this video we are going to control each servo individually at a preset angles. And I have here a push button, so when you push it on the screen, specific servo will move between those two angles. For example, you want an arm to go between 0 to 90 degrees or between 0 to 180 degrees. Whatever angle you want, you can set upper limit or lower limit for each servo motor individually, and also you can set the step of moving. For example, we can set it so it can go in the step of 5, 5, 5, or 10, 10, 10, or 20 or 30, whatever you want, so it can go more smoother or more faster. And make sure to install the library, and make sure to use it without Bluetooth, just connected directly to ESP32. So just connect it to ESP32, either this type or that type, it doesn't matter. The one that I have it says ESP ROM 32, WROM 32. So all of ESP32 modules will work fine with this code. Once you are successful with controlling it using just the code to send this to any angle, then come back to this and apply all this, because if you want me to reply to your comment or question, make sure to subscribe and post comment or question. I will always reply to my subscribers. Let me briefly explain the servo motor. Servo motor is a type of motor that the shaft can be controlled to move only 180 degrees, or half a circle, something like that. And then you can control precisely where it should be between 0 and 180 degrees. There are also other types of servo motors that, for example, there is something called continuous servo, which I have the link below. It will rotate 360 degrees and you can control it. But these are the most common one. And also you might get this type of servo motor, which is very heavy with high torque. It is the same way. It can go 0 to 180 degrees and it will stop. So this is MG966R version, and this is the metal gear. This is all metal, and this is a plastic gear, so this will be much cheaper, like 3 or 4 or 5 times cheaper than this. But in general, this is the operation and you can control it. So the servo motor has 3 wires. The darker wire is the ground. The 5 volts is always at the middle in case you make mistake in terms of connection in RC or car or airplane. So the middle is always 5 volts, and this is the signal. You might see it as a black wire, and this side red is always red, and this side you might see white, but doesn't matter. so they are the same. Configuration is exactly the same: ground, 5 volts, and signal. Let me now explain the wiring. First, prepare 4 male-to-male. These are all male-to-male wires. Align them in the same line. So 4 of these will be used as positive or power for the servo. We are connecting them in here for 4 of them, and then 1 extra here. This is for positive external power. So I have 5 wire here, and then here connect also 4 male to male. These are all for the ground, and then the 5th one is also for the ground. And here are my servo motors. I will start connecting from this side to the positive of servo 0, servo 1, servo 2, servo 3. So I'm connecting it to the positive. The middle wire is positive. That's for servo 1, servo 0. That's servo 1. That's a power for servo 2. And the last one, servo 3. All the positive have been connected. Now I'm connecting the negative from this side, servo 0, 1, 2, and 3. Now all of them, they have second wire. As you can see, the last wire on this side is the signal, the orange. I have this 4 wires here. Is male to female. This side goes to the ESP32. This side will go to servo 0, 1, 2, and 3 accordingly. So I'm going to connect it to servo 0, then servo 1, then servo 2, and the last one will go for servo 3. This is my external 5 volts, the power. I'm connecting this yellow on this side. I'm connecting it to red, to positive. Now I'm just holding them like this and connecting it to pin 12, 14, 27, 26, which are all side by side. This ground from here will be connected to the ESP32, to this pin where I have a ground. And here from my power supply I have to connect another ground to this module. Now I have 2 ground. 1 ground goes to the wiring, 1 ground goes to the external power, because the external power must have common ground with this. In order to start using ESP32 with Arduino IDE, you need to prepare Arduino IDE for that purpose. You will copy and paste it here. You see it says package ESP32 index.json at the end. So once you paste it here, click OK, click OK. This is telling Arduino IDE where to get the board driver. Click on Tools, and then Board Manager. And here, wait for this to complete at the bottom, this bar graph. And then type here ESP32. You see ESP32 by Espressif Systems. It says installed. In your case, it will not be installed. You will have install button here. Click on it, and it will take maybe a few seconds or a minute. And the installation, once is completed, click close. Now we have to tell Arduino IDE which board you're working with, because the driver is ready. Click on Tool, Boards. This is Arduino IDE which you will usually work, but scroll down until you see a line below that. All of these are ESP32, and ESP32 rover module is the one that you click and select, and the dot will appear. Now we have to select the port. For that, we have to find out which port we are using. Right click on the Start menu, Device Manager, and you see port. Click on this arrow to collapse it, and mine is using COM port, Silicon Lab. If I disconnect it now, you will see that it will disappear. Connecting it back. So this is COM6. Note that. Click on Tool, Port, and you will see COM6 is already selected, and now you can write your program and run it. Now let me explain the code. You need to download the library for this. As I mentioned, to download the library, this was the original source, and I've modified it, and I'm providing you the zip. So you downloaded a zip file. After that, click on Sketch, include library, add .zip library, and then point it to where you have saved it. For example, if it was inside this PC and inside download, point it to that and select the zip, and then click Open. This will complete the installation of library. After that, copy and paste the code that is provided from the link on your new sketch, and then we'll run it. Explain. Here, this line, it says include servo underscore ESP32.h. This is part of the library that you have just downloaded. Here we define a constant integer servo count, whatever number you have. If you have 5, 10, just put that number, and that is the number of servo. And here we are defining an array, and this value is used throughout the code as number 4. And here there are 4 values. These are the pins that are side by side on ESP32. You might have a device that is saying G32 on the board, but the number will be just pure number, no G, nothing. Just 12, 14, 27, 26. These are 4 pins side by side on ESP32. And here on this device, as you can see, there is G12, G14, 27, and 26. And here on this one, it says 12, 14, 27, 26, just a number. So it doesn't matter what type of device you have. The numbers are exactly at the same location. If you look at the USB here, they're somewhere on this right side, and also in this one that has USB, they're on this side. Then we create an instance of that class here, and we call it servos, and we have to mention again how many we have. So that 4 is now coming here. After that, we are defining the characters that you want to control using Bluetooth, and this is for first servo, that's a second, third, and fourth. In terms of number, this is servo 0, servo 1, 2, and 3. So we are using character A. You see we have single quotation, and it must be like that. If you put double quote, you will get error, it will not work. So we are using single quotation as a character, and you can put any character that is available on your mobile device, and you can control the servo. So each can be controlled separately, and this is a type. The type is 1 or 2. If you set it at 1, it goes from the servo will go from lower limit to the upper limit and returns back. If you set it at 2, it goes from upper limit to lower and comes back. For example, if you set the angle between 0 to 180, it goes between 0 to 180 and returns back. and if you set it to type 2, it goes between 180 to 0 and back to 180. And here we said this variable is holding the angle for each servo. This is referring to servo 1, servo 2, 3 or 4 and 4 servo, and all of these you see 4 values. These are referring to each servo, and this is a step for servo 1, 10, 10, 10. If you wanted 5 or different values, put those values. These are the values that the servo moves from one angle to the other angle by this increment. If, for example, if the you see here minimum is 10 and maximum for each servo we set 180, between 0 to 180 it goes with increment of 10, so it goes 0, from 0 it goes 10, 20, 30, 40 up to 180. If you put it 5, it goes increment of 5. If you put 1, it goes to increment of 1. So you can set the increment for each separately. The minimum is the lower limit and the maximum is the upper limit. You can change them as you wish, but make sure that the minimum must be the lower value and this must be the higher value. You cannot have 180 there and 0 or some other value smaller than 180 here. But if you want between 90 to 180 for servo 1, put here 90 and put 180. So this is referring to first servo, second, third, fourth, and the same way the maximum for first, second, and third and fourth. And these are the button that when you push it, it is remembered in this variable. Do not change it. And this is the received character that we receive, because when you press it you will receive only one character at a time, and that is being stored in this variable. And include Bluetooth.serial. This is part of serial Bluetooth. Do not change it. It makes sure that if Bluetooth is enabled it will work, otherwise you will get this error. And then from this class we create an instance of the class. Here we call it serial BT, and then we will refer to this throughout the code. And this is a prototype of handle servo. This is a line telling the code that there is a function called handle servo, which I will explain it at the end of the code. Inside the setup we initialize a serial monitor that can display some text for us on the screen here. If I open it, for example, I pushed on the Bluetooth and it print for us that which servo is at what angle, and it must match the number that you have is the same number on the lower side. You see on the lower right side it must be 15,200 or whatever number it is. This is the name of the Bluetooth device. Whatever name you put, it will be displayed on your mobile device when you search for Bluetooth. In this case it's ESP32_Robojax, and it's not a good practice to have space and you might get errors, so make sure it's connected together as one piece. And this is just a text on the screen. After that we have to use a for loop which starts I equals 0 and then I is smaller than count, which is 4. So this I is incremented here, 0, 1, 2, 3. So we go 4 servos, and here we attach them, making sure they are being attached, and if they are not attached we print this text if there is an issue. Inside the loop then we take care of it by reading the Bluetooth value here, serial BT.read. This is reading the value that is arriving from Bluetooth, and we are converting it to character. This is called casting. Inside the parenthesis you put the type, and the result of this will be stored in a receive variable which we defined at the top of the code. And we have here 3 loops. I will explain 3 times. If you are unfamiliar with loop, you should learn it here. So again we are defining an integer I, a variable called I with initial value of 0, and this is called initialization, this is called comparison, this is called increment, and they are separated with semicolon. And when as long as I is smaller than this, which is 4, then continue incremented. So I becomes 0, now it is 0, and it goes 1, 2 and 3, and before it becomes 4 and exits. So this will execute 4 times from 0 to 3, and every time I changes, here we check receive character is equal turn on I 0. This goes and gets the value. This I becomes 0, 1, 2, 3. It goes to turn on. To refresh your mind, here turn on, that's value for the 0, that's the value for the 1, 2 or 3, or this is first, second, third and fourth. So we check it. If that's the value, then we set the push button I, which I refers to 0, 1 or 2 or 3. So we set the push button to 1, which means the button have been pushed, so later on we can take action. And this another loop will take care of moving the servo. So again, I is 0, 1, 2, 3, and here we check the push button. If it is equal 1 or if it is true, this means if this value which is inside this push button here, which we set at the beginning of the code here to 1, so we check if it is 1, if it is true. I could put equal 1, which would have been excess, so we could just use like this. If it is true, then handle servo and pass this I. We put I here, so I is 0 and 1, 2, 3, so this will take care of it, which I will explain next. And this will do the same thing, servo 0, 1, 2, 3, and then it goes to the servo number, servo 1, for example. If I is 1, write servo angle, and it writes the angle, and servo moves to that angle. Then it goes to the servo, to the second servo, and then we have another 20 milliseconds between the loops. So this loop is the main loop, which has 4 loops inside it. You see here, this is the first one, this is the second one, and this is the third one. Now handle servo is a function that is handle servo is now a function that is taking care of the value, making sure that when you increment or decrement the value, it stays within the bound. For example, it doesn't go above 180 and it doesn't go below the 0 or whatever limit that you set. So this portion is taking care of, this line is incrementing the servo, but this portion is taking care of it. If it is above the maximum, it makes sure that it returns back, and this portion will take care of it. If it is below, or if it goes below 0, below the lower limit, it changes the direction. In both cases we have negative here, so the direction will change. That's why the servo moves back. And this portion is printing the text on the serial Bluetooth, and this is printing it on the serial monitor, so we can read the value on the screen either on your computer or on your mobile device. From the Play Store, just type Bluetooth serial terminal. I just type Bluetooth serial terminal, and the first one, the app that you have to get. Here on my app I have defined these 4 buttons here, servo 1, servo 2, 3, 4. If I hold it, you will see on this screen, this is the text servo 1 that is displayed on the screen, and this is the value that is sent using this Bluetooth. So it is now sending A, and for servo 2, if I hold it, it is sending B. For servo 3, it is sending character C, and for servo 4, sending character D. So you set that, and whatever you want to type, I type servo 4, so okay, and that will be ready. The next step, make sure that your Bluetooth is on and it is paired with that device. So make sure to go to the Bluetooth setting, devices and connection, and here Bluetooth on. Then search here, you will see Robojax ESP32, and if I touch it, it will go on the list. So after this, you come back to this Bluetooth terminal, go to a menu, devices, and find the name that you have, ESP32 Robojax, touch it, and it is now connected. This is the sign that it says connected, and also you will see the text here at the bottom, it says connected. If you want to disconnect it, just touch it, it says disconnect, and here also it shows disconnected. So I'm touching it to connect, and here it says connected. Now before I show you the actual servo, I want to show you the screen. So when I press servo 1, it sends, if you pay attention, it starts at the moment it is mode 1. It goes from 170 to 0. It goes from 180 to 0 and then to 180. And the same thing servo 2, servo 3, servo 4. And the servos are connected not in order. This is servo 1, 2, 3 and 4. As you can see, it moves. Servo 2, servo 3 and servo 4. In the code you can set the program limit so it doesn't go all the way. For example, if you wanted to go between 90 to 180, it will do that, or maybe between 10 to 50. Watch this. It goes to that specific limit that you set, and that could be very useful for many applications. And also, if you pay attention here, these items, they go with a step of 10. In the code you can change it. For each servo you can have different speed, so it's the code that I've written is very customizable, and it will work for almost any application that you want. Here you can change the type. Now I've set it to 1. Now I've connected. Now let's go. Now we are in the mode 1. You see the longer pin. And here, now this is type 2. Now I've connected in mode 2. Let me press it. Here, as you can see, it started. It shows that the character that was sent was character A, and servo 1 started. It increments immediately to at angle 10, 20, 30, 40, and as you can see, it goes to 180, and then it comes back to 0 at this point. And the same way, servo 2, it goes and comes back to 0, 3, and 4. Thank you for watching. This was how to control servo motors using ESP32 module with Bluetooth. If you learned something and found it useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, post it at the comment section below. I try to answer and reply. If you want to get updates of my upcoming videos, make sure to subscribe.